This is 2019 paper 1 question 5. We're told a root of this equation. We have to find the values of p and q. So if it's a root, that means that, so if you have a function f of x, if you have a root, let's say the root is a, that means that f of a will be equal to 0. So a root is an input such that the function will be 0. So that means when we plug in 3 plus 2i for z, the entire thing will be equal to 0. So basically 3 plus 2i is a solution to this equation. So we can just plug in 3 plus 2i and we know it'll be true. So you have 3 plus 2i squared plus p times 3 plus 2i plus q will be equal to 0. Then we can multiply out this bracket. So we'll have 9 plus and then 2 times the product of the two terms. So 2 times 3 times 2i. So that'll be 12i. 12i. And then we have the last term squared, so it'll be plus 4i squared, or you can write out both the brackets, up to you. So plus 3p plus 2pi plus q equals 0. So we can do a bit of simplifying, so it'll be 9. And then we have 12i plus 2pi, so how many i's do we have in total? Well, we could say that's going to be 12 plus 2pi's. 4i squared is going to be minus 4, because I squared is minus 1. The question tells us that. And then plus 3p plus q. So the way I've kind of rearranged this is we have all our real numbers over here and our imaginary numbers over here. So since the whole thing is equal to 0, that means that the real part must be 0 and the imaginary part must be 0 in order for the whole thing to be equal to 0. So that means that 9 minus 4, well, that's 5. So this part's equal to 0. So what we can say is 5 plus 3p plus q is equal to 0. Can't really do much with that. But we can also say that 12 plus 2p will be equal to 0. So we can bring the 12 to the other side. 2p will be equal to minus 12, which means that p is equal to minus 6. Then we can sub that into here. So 5 plus 3 times minus 6 plus q will be equal to 0. So 5 minus 18, that'll be minus 13. Bring it to the other side, so we'll get q is equal to 13. So that's our values of p and q. Then we have to write this complex number in polar form. So basically what we have to do is do a little rough sketch. So 2 minus something I, so 2, positive 2, in the real axis, so it's to the right. Then minus I means we're going down in the imaginary axis. So it looks something like this. So we can figure out what the angle is here, because we need the angle theta, and then we need also the distance, which we call r. So if we have a look at this little triangle with theta and r, this side length will be 2, and this side length will be 2 root 3. Don't have to worry about the pluses and the minuses, because these are all distances. Although I think you can put them in if you want. And that'll just give you the answer for the angle straight away. But I like to do it this way just because it's a bit more clear what's going on. So to find out what r is, we can use Pythagoras' theorem. So r squared will be 2 squared plus 2 root 3 squared. So that's going to be 4 plus 2 squared is 4. So it'll be 4 multiplied by root 3 squared is just 3. So 4 times 3 will give us 12. So that means that r squared is equal to 16, which tells us that r, since it's a distance, will be equal to positive 4. So we know what r is. Now we just need to figure out what theta is. So we can say that tan of theta, because we know the opposite and the adjacent, so that's kind of the one you'd probably go for immediately. It'll be the opposite, 2 root 3, over the adjacent, which is 2. And then you can figure out what theta is by doing the tan inverse on both sides. And making sure we're in radian mode, you should get pi over 3. So finally, to write this in polar form, obviously we have to measure the angle from the positive real axis in order for this to always work. So how do we do that? Well, we know that this small angle here is pi over 3. So if this little part here is pi over 3, so we need to do a whole circle, is a way of thinking about it. We do a whole circle, and then we go back by pi over 3. Okay, so what we can say is it's basically going to be a whole circle, or whole rotation, which is 2 pi minus pi over 3. And you can just figure out what that is. So it's going to be 6 pi over 3, so then I'm putting 5 pi over 3 as our angle. Another way of thinking about that is because this angle is going down, you can write the angle as minus pi over 3, but then we want our angle to be between 0 and 2 pi. So, of course, whatever angle we have, we can add or subtract 2 pi. So if our angle is minus pi over 3, we can add 2 pi to that. That's the same thing as I did, just a different way of thinking about it. So now we know the two things we need to know. We can write it in the form, in polar form. So we know r is 4, so we'll have 4 times, and what's this? This is the complex number v. So v will be equal to 4 times cos of 5 pi over 3 plus I times sine of 5 pi over 3. And you can multiply that out just to make sure that we did it right. So when you multiply this out, you should get the same original complex number, because we're still writing it as the same. We're still writing the same complex number. We're just writing it in a different way. Then we need to find two possible values of w, or w squared is equal to v. So what we can do is, well, we know that w squared will be equal to v. And instead of writing v, I'm going to write it as this, just because We can't really work when it's just v, but we can work with it when it's in polar form. So additionally, when we square root this, we're only going to get one answer. We want two answers. So in order to mitigate this, we need to get multiple answers by doing a little trick where we can add 2 pi to the angle and it won't change. In this case, obviously, because it's 2 pi, the value won't change. But when we get the square root on both sides and use de Moivre's theorem, it does matter because we're not adding 2 pi anymore. We'll just be adding pi. So then we can use de Moivre's theorem, which I'll get up now. So here's de Moivre's theorem. And basically what it says is that if we raise a complex number to a power, that's obviously difficult to do. If we raise both sides to the power of a half, we have to half this entire bracket to the power of a half. But instead of doing that, we can do the modulus r to the power of a half and then multiply the angles by a half. So if we do the power of a half on both sides, we do the power of a half and do the power of a half, then we can say that w will be equal to, and instead of doing this entire side to the power of a half, we can just do the distance to the power of a half. So that'll be 4 to the power of a half multiplied by cos of, and then we're going to split this angle in half. So we basically do a half multiplied by this entire angle, which you can just write, but just to make it, I'm just going to do it now. So it'll be 5 pi over 6, because you're dividing by 2, so over 3 becomes over 6, plus pi, because we're doing 2 pi divided by 2, and then plus I sine of 5 pi over 6, plus pi as well. And then 4 to the power of a half, same as square root of 4, so that's just going to be equal to 2. So sorry, I forgot to mention up here, when we're adding 2 pi, we can do that as many times as we want. So we write down 2 pi n for any n in the integers, as long as it's a whole number. We're adding n 2 pi a whole number of times. It doesn't matter. So these should be pi n. Sorry about that. So the idea is that we don't have to add this pi, but we can add this pi to get another answer. So we'll have pi n and pi n. So then for n is equal to 0, which is one answer, we get the w will be 2 times cos of 5 pi over 6 plus I sine of 5 pi over 6. And you can get a number on that because they want their answers in the form a plus bi, so you will have to get a number on that. But then our other answer will be for n equals 1, we'd have w will be equal to 2 times cos of 5 pi over 6 plus pi, because n is equal to 1, plus I sine of 5 pi over 6 plus pi. And we can just get numbers on those because they do want it in the form a plus bi, so you can just kind of put each part into your calculator. So you can put the cos 5 pi over 6 and the sine 5 pi over 6 and see what they are equal to. So up here, when you do that, you'll get these numbers. So then when we multiply the 2 in, it cancels out nicely. We'll just get minus root 3 plus 2i as one answer. And then down here, when we multiply the 2 in, we'll get root 3 minus, or sorry, it's not going to be plus 2i, it's just plus i, because the 2 and the half cancel out. And then here's going to be root 3 minus I, because we have 2 times minus a half times I. And this should make sense, because these two answers are the exact same, except one of them is multiplied by a minus 1. And that should make sense, because when we square something, multiplying by a minus 1 doesn't make a difference. So that makes sense, just for a little gut check.